introduce our next speaker. He's not a new face to us as well. He was here last year. He is the general partner of Hardware Club. This is a private community for global hardware entrepreneurs. Currently, it has more than 160 members, and it provides capital and also resources to its member startups. Ladies and gentlemen, please welcome our next speaker, Mr. Jerry Yang.
Hi, everyone. So it's a small sort of update. So in the world of VC and startups, it's always about growth. So the host just say that we have 160 startups, but right now it's actually 260. Well, anyway, so that's all about startups. You have to grow. So we're a venture capital firm based in Paris. We invest in hardware startups around the world, geographic agnostic, sector agnostic. And it's always kind of difficult to follow Anis to give a speech because Anis' speech is always a lot of media, it's very media rich and a lot of colors. I'm going to do it in a different way. So it's going to be the reverse style. So today my topic is actually a little bit overlapping with Anis' speech. So what we are seeing is that actually, I think Taiwan is a little bit lacking in the trend, the cycles of the Silicon Valley investments. And for past couple of years, we talk a lot about, what's the lean approach, which was kind of foreign to many of the people here who did high tech for so many decades. But then, actually, in Silicon Valley, the investment trend started to shift it again about 1.5 years to 2 years ago, back into what we call the deep tech. And when Anis talked a lot about the AI and deep learning, machine learning, which is actually one of the the categories that falls inside the general broad trend of deep tech investment. So today I'm going to do some qualitative comparison and try to explain why the money is now flowing back into deep tech. So a little bit of the recap. So how did lean startups started? So lean startups basically it's basically a trend where you don't need to be a guy from Stanford you don't need a PhD from MIT. All you need is an idea, and with the right approach, you can trial and error and just bootstrap yourself to hyper growth. And the reason that happened was because actually we all know Moore's law. So Taiwan is very familiar with semiconductor and Moore's law. So Moore's law, if you're familiar with it, you understand that it's actually not concerning the supply and demand. So the idea of Moore's law is that the density of the transistors is going to double every 15 to 18 months, regardless of whether the world wants it or not. So what we have here is a graph that is the transistor number of Intel processors all the way back into the 1970s when they first started, and I have the data up until 2015. And if you notice that the vertical axis is actually log scale, so which means that when you plot the Moore's law across the timeline, it becomes a straight line. So you look at the yellow line, it's almost like straight. And then, so that's the processing power. But if you look at the bottom line, this bottom line is labor productivity. So normally when we look at the tools, if the tools become better, you should have higher productivity. But what we're seeing here is actually the labor productivity of the United States has barely doubled, so which means that on a log scale, it's actually flat. And so what happens here is that you have a processor that is progressing very, very fast, but the application didn't catch up, which is why productivity didn't catch up. And that created a huge gap here. So if you look at the history, so you have Apple I, Apple II computers, then Netscape was invented, then Windows 95 hit the market. Throughout this period, it's still fine. You're still using up to most of the processing powers of the CPU. But then around 2003 and 4, something happened. You do not need that processing power anymore. You don't use 100% of your CPU anymore. Your CPU is running at 15%, 20% most of the time. And this is where lean startups were born. Because now you have a huge gap between what the processor can do and what people are doing. And so you can turn the paradigm around. And now you focus on user experiences and users' interface and all that. And this is where the startup revolution happened. So this is what I call the processor bonus, which is the fact when you have a very powerful processor, but you don't really use up to all the power. And that changed the way you create tools that can help people. So that's the background of the lean startups. But what happened is that So in terms of lean startups, there are a couple of philosophies that now we are very familiar with. So you have the MVP, you have the iteration, you have the user experience UI, you have the acceleration. Of course, you have Mark leading the whole thing. I remember when Facebook filed for IPO in 2012, I was still in Silicon Valley, and so I was working for Qualcomm, and the entire office gathered together. We look at Facebook and say, how could this company be possibly launching an IPO that is like $40 billion or $50 billion market cap? It's impossible. There's no tech inside Facebook. So that was lean startup. You defend your business in a different way. So what's happening now is that actually back in 2015, so Eileen Lee was formerly a partner at KBCB, and probably I need to know her as well. So in 2015, already after 10 years of lean startup boom, all the investors are coming in, investing in all kinds of app-driven, so app-driven startups, internet website-driven startups. We realized something that, okay, actually the lean startups are not very capital efficient. So we're under the impression that, okay, you can get a startup off the ground very quickly with very little capital. But what happened is that after it goes into the growth stage, it has to compete with all the other copycats because basically everyone is doing the same thing. It's very easy to copy the idea. So it becomes very, very capital intensive when you go into the growth stage because you're competing with the other copycats. You have to, similar to, for example, Uber fighting Lyft, similar to in China, like Didi fighting Kuaidi, and they have to merge, and now they fight Uber, and they have to merge again because you're just fighting to get the users, and you're wasting your money just trying to acquire the user. So that was a fact. So capital efficiency was very low. So what is capital efficiency? I talked about this a little bit last year, about a year ago here. So if we broadly define that as a valuation or the IPO market cap divided by the VC money raised, so the higher the capital efficiency, it means that you're using the capital much better, and it potentially would generate more return for you, your team members, and your investors. If you look at the IPO of Facebook, when Facebook IPO, the capital efficiency was about 36 times. So the market cap divided by all the VC money they raised. When Twitter hit IPO, it was 22 times. So the Uber number, Airbnb numbers are a little bit old, but this was from a little bit like 6 months ago. We're looking at Uber and Airbnb. It's not very, very capital efficient. So already Uber was like down to 5.7, and I think they did a small run. I think earlier this year it's gonna get lower. The same thing with Airbnb, so it's probably around 9 or 8.8-ish. Okay, so what happened here? How come the capital efficiency was not very good? Because, like I just said, because they're competing against the other copycats to acquire the users. So a lot of money was wasted in burning to acquiring a user. So given that backdrop, which happens so the whole thing pretty much peaked out in 2015. So now actually, we don't really talk about it because we have to place the bets before the market knows it, but the money has been flowing back steadily, and now it's accelerating into what we call a deep take. So what is deep take? Exactly what is deep take? So before lean startup rise, actually all the technologies are deep tech. This is something that in Taiwan we're very familiar with. It used to be that you have to go to get a degree in National Taiwan University or in Stanford, MIT, in Berkeley, get a PhD in EE in computer science, and then you'll be able to work in a high-tech company. And something that happened during the 10 years of lean startup boom that we're not familiar with is that, okay, you're seeing some kid from around the corner starting something, doing an app. But now it's back because, before this whole lean startup revolution happened back in the 90s where we're familiar with, everything is about deep tech. So you look at computing, hell, back then building a computer was not very easy. You just have to put in a lot of the knowledge to do it. That's how ASUS was successful. That's how Acer was successful. Telecom companies, technologies, Datacom, so I used to work for Acerus, and then we merged with Qualcomm, so one of the leading Wi-Fi development companies. Semiconductor, which Taiwan is very familiar with. Server, like for a while, even servers are super difficult, right? You have to spend a lot of money to buy a Sun microsystem server, database, OS, and not to mention enterprise software. So for a while, in the 90s, every take was very deep and very difficult. So what is the difference between the take back then and now? If you look at, for example, all the previous technologies, there's one thing very, very interesting. They are all part of the value chain. What does that mean? It's not integrated because it's so difficult, so it takes so many players to make the entire industry work. So if you look at every segment of them, it's all like horizontal. So you have computing. So computing technology, computers, is just part of the entire picture. You look at server, you look at database, it's just part of the entire picture. And you can build a successful company just on part of the entire sector. So what has changed? What has changed is that all of those things now become something of a given. You have very powerful server, you have the cloud, you have everything that drive all the digital revolution. So now what's changed is that on top of that, now you have several very powerful tools that will bring integral services to the consumers, to the enterprises. And on top of that is, of course, what Anis already talked about a little bit about. So this is what everybody's talking about now, is what we call the artificial intelligence. But to a more specific meaning, it's actually machine learning and deep learning. So deep learning is part of the machine learning that's happening right now. And that's one of the fundamental driver of all the deep technologies today. But then there's also the quantum computing. So not many people talk about this, but several very famous VC firms in the United States already started to bet on quantum computing. Unlike the AI that went through a couple winters, so quantum computing has always been an academic thing, but now it's back in the vogue. People are putting money into it. And not to mention robotics, which has been going on for a couple of years. All kinds of new sensors that's happening right now, whether it's MEMS or, for example, in our case, we invest in an older sensor. And then all the other things, now if you add machine learning and deep learning, it changed the meaning. So we talk about IoT all the time, but what is IoT? Is it just about connecting to the internet? No, if you drive everything on the back end with deep learning, that changed the entire value proposition of the startup. And medical technologies as well, food tech, clean energy. So some of the sort of features is that first, today, the deep tech is trying to tackle what we call the frontier challenges. So now you're trying to push the envelope of the human technologies again, instead of just trying to provide another way to allow people to hail a taxi or try to find a place to stay. There's also, you have to leverage the entire internet infrastructure that we all know, and you want to be lean inspired. So you cannot apply all the lean strategy, but you can still be lean inspired. And it's a lot of them, so if you look at the previous picture, those things don't touch, most of them don't touch the consumers. They touch the other industrial players. But now, a lot of these things would directly interact with the consumers. So that's really what we have come to today, which is actually, you can actually have a startup that's doing something very deep, but it touches on consumers very straightforward. So what's happening? Let's come back to this graph. What's happening is, with the advance of all those things, we are closing the gap. So for a while, the CPU was operating at 15-20%, and you're talking about, can I design a landing page that attract 20% more users to give me the email address? Can I do an A/B test so that my web page is more attractive? But now with AI DL, so funny thing is I bumped into Jensen Huang yesterday in Grand Hyatt. So I just took a selfie with him. He was, for whatever reason, he was alone, the founder of NVIDIA. And then so we were talking about this. For a while, people say that I don't need powerful CPU. I just need an ARM. But all of a sudden, with AI, deep learning, and machine learning, everything is now back. So you snap back to this trend, and now all the CPUs are 100% operating again. Okay, and that changed a lot of things. So now you're hearing household names. So NVIDIA, last year, the share price tripled. And right now, the market cap of NVIDIA is $88 billion. Last time I checked yesterday, $88 billion. Do you know the latest market cap of Twitter? So we talk about Twitter and Facebook all the time. The latest market cap of Twitter is now only so $14 billion. So now NVIDIA is now worth more than 5 times than Twitter. I mean, for people from the old age like us, it's kind of a nice story to have. So we have NVIDIA, we have Intel acquiring Nirvana Systems, and we have Google doing their own AI chips. So now a lot of the hardware, a lot of the sort of like very complicated techs are now back in the vogue. So today's deep tech, if you're starting a deep tech startup today, so there are a couple things you want to keep in mind. The first thing is that there's no such thing as MVP. You just have to get there. So there's no minimum viable products. You cannot roll out a product that is not complete. And you have to, the team members have to have deep domain background. So in terms of accelerations, and those things will be there, but for deep tech startups, it's very difficult if you don't have, for example, if you don't study machine learning or deep learning in Stanford or in all the major colleges. And a lot of things now back to textbook series. So now we're back to Maxwell equations, we're back to all the algorithms that torture us for a long time, which is kind of nice for people like us. It might be capital intensive, but it's not necessarily capital inefficient. This is very important. There's a difference between capital intensive and capital efficient. You can be capital intensive, spending $200 million, but if you can do a $2 billion exit, that's a 10x capital efficiency, better than Airbnb and Uber right now. Okay, and the product to market time is now less certain because you don't have the MVP. Okay, and what does it mean for the investors as well? So for the investors, again, there's no or little acceleration you can do. There's just nothing you can accelerate. You just have to put your heads down and let the startups do their job. And also the VC have to have deep tech knowledge, or you have to have an expert network that is strong enough to help you do due diligence. You probably need to have a deeper pocket because some of them might need 2 or 3 more rounds before they can hit anything to the market. And of course, passions. Okay. So I'm going to go through very quickly in each and every one of those deep tech sort of category. What's the main thing you should be thinking about when you start a company? So first thing, let's talk about the talk of the streets. Everyone is talking about artificial intelligence, machine learning, deep learning. So the first question you have to ask yourself is that a lot of people are doing pure software, machine learning or deep learning startups. Does that make sense? So one of the things about machine learning and deep learning is that you need data set to train. You need input data set. If you don't have the training set, you're just wasting your time. And that's one of the challenges for many of the software startups today doing AI, because they realize that they do not have the input data. Many of them came from the background of academic research. They did open source. They use open source data set to train their algorithm. For example, ImageNet by Stanford is one of the most famous data set. So when they start their own company, they say that, okay, I have a very, very powerful algorithm. I know how to really build something. I'm super smart. I have an IQ of 240. And they tried to do something like smart building, and they couldn't because there's no open source database for smart buildings. So they go to the real estate developer and say, look, I have an algorithm. If you just give me your sensor data, your energy, give it to me. I'm going to train it for you. And the real estate development look at them and say, no, I'm going to hire my own people to do that. Okay? So you have to think about, if you're doing machine learning or deep learning, you have to understand whether you have the data to train your algorithm or not. If you don't, maybe you should think about creating what we call the full stack AI startup. And that's what at Hardware Club we're betting on. People who build all the way from sensors to the hardware, all the way to software and machine learning, deep learning. It's not necessary, but if you don't have input data, all bets are off. In the space of quantum computing, a lot of people are talking about, so today we're doing a lot of the very, very heavy calculating still on computers, so on what we call the binary computers. But in terms of the investment, a lot of VCs are now really, because they're seeing that actually quantum computing is back. And some of the early science shows that maybe we're nearing to a point where quantum computing, after decades of like academic research, now is going to be finally commercialized. Yeah, so is singularity point near? Should we replace the Moore's law that's in the binary world with the quantum computing? But can we scale quantum computers? So that's the big question. So I think some of the people in Taiwan actually did quantum computing research. I have a college classmate that actually did quantum computing research back in the 90s. And for a while, they couldn't find a job. But now, like all the AI people, now you actually can find very good jobs in the most state-of-the-art startup in the United States. Okay. Robotics, again, are you going to do B2B like, Anis talked about Coca, one of the largest industrial robotics players. Are you going to build B2B robots, or it's going to be B2C? A lot of people try to build B2C robots, but are consumers ready to have a robot that doesn't really do anything in your home? You have to find the right way to break into the market. And again, there's always the scalability and manufacturing problem. Sensors. Many of the sensor startups today, so we do a lot of sensor investment. A lot of the sensors are just combining off the shelf, let's say sensors from ST Micro or from NXP into a new application. That's fine, that's fine. But there's also other routes. Like today you have many fundamental components that you can use to build something from the scratch. You have to figure out which one you want to go. And again, there's also the value chain proposition and also the scalability. So IoT, I mean, I need to talk about that, and we do a lot of IoT. So whatever you do, keep in mind, if you don't have a backend that was analyzing the data, analyzing all the environment statistically you're collecting to give a useful application to your enterprise clients or users, then it's going to be meaningless. MedTech, I want to spend a bit about MedTech because I was reading a lot of things that happen in here, and it's really like across the board. So I was reading paper on Nature magazine. So if you know Nature magazine, that's like the Bible. That's like all the researchers in science engineering, that's like the holy grail you want to get to. So it was a paper published in February by a Stanford PhD student in collaboration with the medical school students. So what they do is they do machine learning on skin cancer. So some of the skin cancers are pretty put it this way, nasty, and actually very, very high lethal rates. But you cannot discover them in early stage unless there's a certified dermatologist that look at the photos or look at your, basically did a treatment on you. So they did a research, and they were able to build a machine learning algorithm that beats 22 board certified dermatologists in the United States. So they're much more accurate than those people. So now comes the question, or comes the problem. So the whole training was built on open source database and as well as private database, which is about 120,000 photos that they collected. So they actually share the library. So you build an algorithm, and then you bring that algorithm into, so let's say you want to start a startup that will help a lot of people that might suffer from skin cancer. What's the problem next? The problem is, yes, you have the algorithm, but the problem with most of the medical question is that it's not about whether I can diagnose whether you have this disease or not. It's that the patients do not know they need to do the diagnosis. The patients do not have symptoms that would drive them to the hospitals. Right? I'm having a cold here, so I'm sorry I'm coughing. So if I have a cough, I'll probably take some medicine or probably even go to the doctors. But a lot of the cancers, you simply do not have symptoms in the early stage. That's the biggest challenge. So you don't go to hospital. And in Europe, so I'm based in Paris, in Europe, if you go to the hospital, you have to first go through the home doctors, the general doctors, that if they think that, oh yes, it's worse for you to go see the specialist, dermatologist or something like that, then they'll send you to the dermatologist. So if the home doctor could not understand, could not diagnose that, yes, you're potentially having the skin cancer, you will never get there to be able to use the algorithm to do that. So fundamentally, what's going to change here is that, so in this scenario, what I'm going to propose for this kind of startup is that you should not just have the algorithm. That's going to be there. It's going to be powerful. But you should create a device that is low cost enough that allows anyone, so anyone here, for example, if you have something on your face or something, you're worried that it's a skin cancer, you can actually take a picture, upload it to the cloud, and the algorithm will be able to tell, okay, there's an 80% chance that it's better you go see the doctor and do a more deeper analysis. And that's what's going to drive the real innovation in medtech. So that's something I want people to really think of, because I've run into so many startups told us that, look, fine, I just had an algorithm, that's fine, people will be taking pictures for me. No, people won't be taking pictures for you because they don't have the symptoms, okay? So they won't be doing that. Also, just one more thing. So a lot of things in medtech are really gating the FDA regulation. So here in town we have our own regulation, but in the United States it's really about FDA. Some of the things in FDA really should have to change. So we have one startup that was able to, so they have a patented technology that allows you to customize your own pill. So you can deposit different kind of ingredients into your capsule, and it will release in different time. So it's about customize your own drugs. But the problem is in FDA process, every single drug, if you change the composition of the drug, you have to redo the whole process again, which means that customized drugs is impossible, even though it's better for human beings. So those kind of things are going to be given the new technologies today that allows you to do that, it's going to be the new challenge both for the startups and the FDA regulators. Food tech, actually Silicon Valley has been putting money into food tech. Some of them are really funny for a couple years now. So the famous one would be, I always forgot the name, but it's the one that Peter Thiel put money into, which is synthesized eggs. So instead of just having chickens laying eggs, but you now synthesize eggs from plants. So I think, I don't want to spend too much time on this one, but basically you have to understand, I think any startup has to understand, if there's a food problem, is it a distribution problem or is it really a supply problem? So in the case of food, there was a very famous debate between Peter Thiel and Eric Schmidt, the former CEO and currently the executive chairman of Google, they really have a huge debate because Eric Schmidt, like me, feel that it's a distribution issue. We have enough food to feed all the human beings on Earth. It's just a problem. Americans are eating too much and wasting too much. I'm sorry if there's any American friend here. But PhD firmly believe that we have to synthesize food, it's a more philosophical question. This is the last one. So in terms of energy, a lot of the startups are doing new energy, so let's say energy devices, either energy creation or sort of increase the efficiency. So the first question is, are you trying to increase the conversion efficiency or consumption efficiency? That's a fundamental question. Are you doing a device that is lower power, or are you trying to allow the way you convert from, for example, from oil all the way to energy in a more efficient way? The biggest champion of this one, conversion efficiency, is actually Tesla Motors. So Elon Musk pointed out something very important. So the problem is now you have fossil fuel. The problem is fossil fuel today are being burned in combustion engine in the normal cars, which has anywhere around 30% to 40% efficiency. That's very low. That's why you're wasting a lot of energy in fossil fuel. Now imagine you do an electric car, and then you move all the fossil fuel to the power plants. There, with a much larger, let's say, plants, you can achieve 90% efficiency. So now you change the whole paradigm, and now the whole equation now starts working. You don't necessarily need solar energy or something like that. Okay. So with that, I conclude my speech. I think today is really exciting time where for many, many years, we talk about startups, we talk about innovation. But now we're seeing a lot of the new deep tech startups, they're pushing really the frontier. And it's no longer just sci-fi thing. And so I think it's a good time for, Taiwan has been investing a lot of money into some really fundamental science. But I think for a while, we were sort of scared that, okay, everybody's doing an app. Maybe I should do an app. But now the good news is that this is the good news. The good news is that even Silicon Valley, money is flowing now back into the frontier technology. But you have to do it in a newer way, in a more modern way. And you have to keep the inspire mentality and not just, closing yourself into the lab. And that's my last message to the audience today. Thank you very much.
Thank you, Jerry.